You are listening to the Wi-Fi Ninjas Podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hello and welcome to the Wi-Fi Ninjas Podcast. I am your co-host, Matt Starling, and joining my co-host, Mac Daring. But we have a special guest on the show today, Mr. Andrew VonNagy. Hello, both of you. How are you first, Andrew?
Doing great. Thank you guys for having me today.
It is our pleasure to have you on here. How are you, Mac?
Never been better, as always. Thank you very much for asking. And how is it going for you, Matt?
Very good, thank you. So, Andrew, where in the world are we speaking to you today?
I'm in Omaha, Nebraska, right in the middle of the U.S.
Oh, wow. And you work for a company called Celona, is that right?
Correct, yep,
Yeah.
Celona.
God, I'm trying to make sure I get my pronunciations right.
Yeah, think of it just like the city Barcelona.
Okay, that makes sense. And so I did see that you done not only did you do a deep dive session at WLPC at the beginning of this year, but you did a talk at the conference as well. Is that right?
Yeah, I did a deep dive 2-day session on CBRS and Private LTE. Introductory content to get people familiar with both the spectrum and the technology. And then I did a short presentation on our Solona network planner, which is kind of a first step at determining how many APs you might require for a specific deployment. It's a free web-based tool, and it's the entry point for budgeting and planning purposes.
Amazing. So I should probably just call out now that we are recording the video for this as well. So if you're listening to this on a podcast and you like what Andrew says and talks through the demo that he'll be going through with us later, you can go onto our YouTube or onto the website and you'll be able to see the demo as well. But maybe if you want to give the listeners a little bit more of a background about yourself, Andrew.
Yeah, absolutely. So my name is Andrew VonNagy. I've been in enterprise networking with corporate networks for route, switch, security, client server, and then my specialty has been Wi-Fi. I've been doing that for about 20 years across all of those. Wi-Fi for a bulk of that, 15 plus years. And so, started off here in Nebraska, in the early 2000s, and was doing a lot of the route switch, security type stuff, and was tasked with jumping into first wireless deployment for a local school district. And they tagged me as a security guy because wireless back in the day was, very, a lot of anxiety about the security of Wi-Fi. This was back in the old WEP days. So they tasked a security guy, me, with, getting Wi-Fi up and running in a secure fashion for the school district. So that was kind of my entry point into wireless and Wi-Fi, and kind of off to the races from there, since there's just been a lot of opportunity, a lot of need in the Wi-Fi space, especially as that was emerging and rapidly growing over the last 10 to 15 years. And so kind of just fell into wireless doing that. I've worked for large Fortune 50 companies like Target since then, doing their distribution centers and warehouses. And then I moved over into the manufacturer space, working for some Wi-Fi manufacturers like Aerohive and Airtight. And then some managed service providers along the way as well. And now I'm with Celona, jumping into another kind of emerging market with private cellular networks that enterprises can own and deploy themselves. And, it's very interesting times for that. So I find myself kind of back where I was, 15 to 20 years ago, starting my journey in Wi-Fi. So it's kind of interesting.
I almost find that quite hard to believe that you've been working in Wi-Fi for so long, because you look younger than me.
That's exactly what I wanted to say. It's like you look like 25, so you are working in Wi-Fi since you are 5 years old?
I actually just celebrated my 39th birthday a couple days ago this weekend. So
wow,
happy birthday!
My wife has given me plenty of grief about next year turning 40, so we'll see how that goes.
Yeah, and not only just talking to us today, but this will be recording this on the same day that you're going to be presenting at the Mobility Field Day as well.
Yeah, our team is excited. This will be the second Mobility Field Day we're going to present at. The first one was embargoed and released a little bit after the event because we were still kind of in stealth mode as a startup. That was last September, and since then, we've come out of stealth mode. The last year we've been working hard on not only product development but active evaluations and proof of concepts with real partners and customers out in the field to validate the technology. And we kind of been on that journey along with the rest of the CBRS kind of market as it's moved through FCC certification and launch. And so in January, CBRS went live essentially in the US for full commercial deployment. And we've had live deployments out there for about 9 months now and been learning a lot. And we're, getting close to, product launch on our side. So it's very, very exciting.
But be honest, what were you more excited about? The Mobility Field Day or recording a podcast with us?
For me, everything's kind of, since I've been in the industry so long, everything's just kind of one big Wi-Fi community, even though it's Tech Field Day and they do a lot of other, events, and Mobility Field Day is not even, one of their bigger ones, I don't think. But I've just known the guys forever. So everybody's just, it's more like friendships and you just talk with people. So there's no preference. You guys have been making great inroads, I think, with your new podcast. So a lot of excitement out there about all the content you guys have been creating. So I've been hearing good things.
Thanks. I think we'll just cut out that bit you said before and just keep that last bit. So it sounds like you just meant us.
Yeah, sounds good.
No, thank you very much for taking the time to come and speak to us, because I actually feel like I'm going to learn quite a lot around CBRS and private LTE, because it was on my to-do list to watch that video from what you did at WRPC, but it's just one of the things I haven't got around to. And because I don't feel like it affects the UK too much, the private CBRS space, and what I've heard, I've kind of not really looked into it too much. So I'm looking forward to listening to what you've got to say today, because even if no one else does, I think I'm going to learn quite a lot from it.
Yeah. It's, CBRS is fairly specific to the US with the FCC regulations, but there's similar initiatives. Germany has some lightly licensed spectrum already. I know the EU and the UK are looking at very similar kind of concepts. So it won't be long before these types of shared spectrum initiatives are available in your country. So good to get ahead of it. And I think a lot of people are looking at what the US is doing. And then, if you're prepared, all the better.
Yes, it couldn't seem like a better time to really have this podcast, because it will force us to learn a bit more and know a bit, and we'll be ready.
Yeah, the journey to learning LTE and 5G technologies is not a short one. So there's a bit of a learning curve, just with accessibility of some of the information, as well as, just learning the technical content itself. So it's good to get started early, I would say.
Yeah, definitely. So maybe if you could start with just a technical overview then of CBRS and the private LTE/5G space.
Yeah, absolutely. So CBRS is the core foundation, which is essentially a new spectrum band in the US from 3.55 to 3.7 gigahertz. And this spectrum band has been opened up for shared or tiered access. So it's not licensed, it's not unlicensed, it's kind of a hybrid in the middle. So what we have is essentially incumbent users, which are the Federal Department of Defense and military, who have used this band for some of their operations, but they don't use it very heavily. So this started back in, I want to say 2012, with the White House and the NTIA, which is another organization within the federal government, looking at what spectrum they could open for more broadband and cellular technologies. And this band was identified pretty early on as very lightly used by the US DoD. So essentially what we have now is the FCC's come out and said there's a 3-tier system to this spectrum band. The first tier is incumbents, which is the US military. If they're using it, everybody else has to kind of avoid the pieces of the spectrum they're using actively. The second tier is priority access licenses. So they're going through the auction as we speak, essentially. So on a county by county basis in the US. So US, you have the states, and the states are broken down into counties. And each of those counties then will have a bid on them to win some of the spectrum. So of the 150 megahertz, up to 70 megahertz of it can be auctioned off for the tier 2 users. So tier 2 users still have to defer to the incumbents, and then they would have priority access after that to a subset of the spectrum. And then the third tier is the general authorized access, which is similar to unlicensed, although it's much cleaner at this point than unlicensed spectrum, since really the only thing going to be deployed in this band is cellular technology. So you won't have all the other types of unlicensed type of technologies deployed. So GAA then would back off and avoid spectrum that either the license holders are using or the incumbents. And it's not kind of an all or nothing. The incumbents typically will only use 5 to 10 megahertz of spectrum at a time, and typically this is only along the coastline, since this band was used by aircraft carriers. We don't know exactly what the DoD used it for, but we do know it was used on aircraft carriers. And so the three main areas that might get impacted by the incumbents are the aircraft carriers where they kind of come into port, which is Virginia, San Diego, California, and Seattle, Washington. So if you're not really in one of those three areas, probably minimal chance you'll get impacted by the incumbents. And then it's also not all or nothing as far as backing off license holders. Let's say a license holder wins 40 megahertz of spectrum in your county. They actually have to have an active live deployment, and then interference is modeled on a radio by radio basis to determine if your radios can or cannot use that spectrum. So really what the whole scheme is set up is it's not a blanket license. It's really just more, there's a lot of back-end interference modeling, and if you deploy a radio at a very specific GPS coordinates, they're modeling to determine if you're going to impact any incumbent or priority license holder. And if you do, then you just have to use a different channel. So most cases out of the 150 megahertz, we're seeing enterprises that we think they're going to realistically have about 110 megahertz at least available to them to use for their own private networks.
Okay, so we have 110 megahertz available to enterprise customers, which, when you compare it to Wi-Fi, is not too much. So how can you use it as efficiently to compete with the Wi-Fi in terms of delivering data to and from your wireless clients? How does it work?
Yeah, I think there's 2 points to unpack there. One is the efficiency point that you kind of alluded to. And the second one is you mentioned competing with Wi-Fi. And I think we need to take a different view on that, as it's not necessarily competing with Wi-Fi. It's an alternative option to Wi-Fi that can be used in parallel for specific use cases. So we see them more as complementary. So if I unpack the first one, efficiency, 110 to 150 megahertz seems like quite a bit less than what Wi-Fi has access to. But when we look at the characteristics of LTE as a protocol, there's some things that allow LTE to more efficiently use the spectrum and reuse the spectrum more often than we do in Wi-Fi. So we can actually get more AP density, more client density, and more throughput per megahertz or per given quantity of spectrum with LTE or 5G. And that's really due to LTE and 5G's interference handling. So with Wi-Fi, you guys are probably familiar with contention and backoff, right? So if one transmitter is transmitting, anybody else who can hear that and decode the preamble backs off, and they completely remain silent until they have an idle slot to try to transmit on their own, correct? Yep. So in LTE, that is not the case. So LTE has a lot of coordination on the back end between APs. So if it's within your own network, co-channel interference is managed and handled through scheduling on the back end. So if your network is not completely congested, even if two APs are operating on the same channel, they will essentially synchronize and schedule their transmissions across the time domain such that they don't interfere. So you'd have, one transmission from AP1, the AP2 would have a scheduled transmission directly after it. So if you have, a very lightly congested network, they're scheduled in that fashion. The second big factor in that efficiency is that even if you do have a congested network and they need to schedule transmissions at the same time, they don't back off completely. It's not all or nothing. So what happens is they can transmit simultaneously, and the transmissions from the other APs or clients on the channel just really is interpreted as raising the noise floor. So you can still have simultaneous transmissions, but they might have a raised noise floor to a degree, and maybe, let's say, a lower modulation or data rate for their own transmissions. So you can still layer in additional capacity and reuse that frequency more often than you can in Wi-Fi, but it does come at some trade-off with a lower data rate. So you still need to design for proper interference handling from a AP placement and a channeling perspective, but it's not quite as critical as Wi-Fi to get it to minimize that co-channel interference.
So this is very new to us. So just to reiterate, we have better scheduling mechanisms in CBRS 4G, LTE, 5G than we do have in Wi-Fi. And in the Wi-Fi world, to fix this, we started using OFDMA, that is in early days, and this will be very similar to how CBRS is operating. However, it's not as advanced in development from the perspective of the scheduling mechanisms as CBRS is. And then,
as LTE is, yeah. CBRS is really just the spectrum. It's LTE and 5G is the protocols running in the spectrum, yeah.
Yes. And then secondly, in Wi-Fi, when we have two transmissions happening at the same time, which can happen in congested networks, we would just have a backup timer, and then you have another collision, then the backup timer will be twice as long. And in LTE, we don't have that. So both clients, they will talk on top of one another. That will just lead to increased noise flow for the other client and lower modulation. That's amazing. What happens if you have multiple clients in a similar distance from the base station or from the access point? If the SNR is not good enough for these clients to transmit, is this still going to be somehow useful, or you do have a possibility to retransmit your data?
Well, so I think there's an interesting point there that I think I can elaborate on before I answer that direct question on the two clients, is that the LTE and 5G access points schedule all transmissions uplink and downlink. So for multiple clients within one cell or within one connected to one AP, the two clients will never talk over one another. The base station of the AP is telling the clients when they can transmit uplink as well. So we kind of avoid any clients interfering with one another within the same connected to the same AP. So that's really only an issue then if you have clients connected to two different APs that are close enough where essentially they have such a high signal strength with one another that the noise floor is high enough to prevent that simultaneous transmission. And yeah, that's one of the design constraints we have to work around when designing the network is we can pack in more APs and not be quite as concerned about co-channel interference, but there comes a point where they're close enough together that the noise floor gets high enough that it still will prevent those transmissions. So that's more just like a packet error that gets dropped and then it has to be retransmitted. There's also very robust retransmission techniques that probably a little bit more advanced that when you get into them to prevent full retransmissions of frames. It's called hybrid ARQ. So really essentially it boils down to you're only retransmitting the specific pieces that were not able to be demodulated. So you can receive 80% of a frame correctly, and if some symbols were corrupted, that's all that needs to be retransmitted as well.
That's quite an interesting concept. So you don't have to retransmit entire frame or transmission, you just retransmit bits that require to be retransmitted.
Correct.
Okay. So now CBRS is a private LTE 4G or 5G thing. So do you use either 4G or 5G? Do you care which protocol you use? Is it still both considered to be CBRS if you use it privately?
Yeah, CBRS is just the spectrum band with the FCC or the regulatory requirements around certification and the incumbent protection aspects. So you can essentially use any protocol on top of this as long as it meets those requirements. So today that's 4G LTE. Very soon, within the next 9 to 12 months, we're going to see 5G. As it becomes more commercialized, be adopted and deployed into that spectrum as well. And actually very early on in the process of creating the CBRS spectrum band, the Wi-Fi Alliance was looking at it as potentially deploying Wi-Fi into the band. They have since abandoned that. They didn't feel it was a target for them. But just to highlight the point that it's just a spectrum band and it's open to any protocol. The only real ones that are getting commercialized, though, are LTE and 5G.
So you're probably not going to see it too fast in the UK now that Huawei's been pulled from the 5G infrastructure. It's going to cause a bit of a delay.
Well, probably it's like you are not using Huawei equipment anyway, right? You have your own, I would assume.
Yeah. So the big advantage then to CBRS is that cellular technologies have always kind of been locked behind the mobile network operators. They controlled it. They bought licensed spectrum. They were the only ones that deployed this technology, right? So with CBRS, it's really a spectrum property that makes cellular accessible for everyone to own and deploy. So no longer do you have to go to the MNO to deploy a cellular network. You can buy equipment and deploy it yourself, just like you would your own private routed switch Wi-Fi network, right? So Celona, we're a wireless manufacturer for private cellular technology. So we have an end-to-end solution that includes the access points and the radios for LTE. We have the cellular packet core, which we call the Celona Edge, that does other functions for the spectrum management and the integration for the FCC incumbent protection and things like that. And then we have a cloud management piece that does orchestration of policy, has front-end APIs for DevOps type provisioning and policy automation, as well as streaming telemetry for getting metrics out of the system. So we kind of provide all of that, and you could buy it from us and deploy it and own it yourself.
So,
okay,
sorry, I was just going to say, so our private LTE or CBRS deployment similar, if you're looking at it from like a wireless deployment perspective, where you keep referring to them as APs as well, so you would call the LTE APs. Do you have controllers, like wireless LAN controllers, like the same as you would with a Wi-Fi wireless LAN controller, or cloud-based like Meraki or Mist? Is it very similar, like quite a easy transition from Wi-Fi to cellular in that perspective? Like you refer to the technology similar to what you would with Wi-Fi, or do you call them something different? Or
from a Celona perspective, that's one of our goals, is to make it as seamless and frictionless as a transition as possible. I think if you look more broadly at the market, no, cellular is quite a bit different in architecture typically than Wi-Fi, but we're trying to make it so that transition is seamless. So we're calling like for instance, terminology-wise, in cellular they call the APs eNode Bs or Evolved Node Bs. From a Celona perspective, we're calling ours Lte Access Points, just to ease that transition, that terminology barrier. And so that's one of our big goals, is rather than pulling in a whole separate network for your cellular network, like pulling in fiber to your own antennas, and like you would traditionally, putting in a rack of $1 million worth of gear to have the baseband and the cellular packet core. Our solution is designed from the ground up to really be adoptable by the enterprise very easily. So we have LTE access points that look and function very similar to Wi-Fi access points. So we have indoor and outdoor model. There are 2 radios in each. The indoor has internal antennas mounted on ceiling or walls, just like you'd be used to. The outdoor has N-type antenna connectors. It's IP66 rated, so you'd buy the AP with some external antennas. The packet core and the cloud management are all software-based, so it's very flexible. You can deploy it on an existing virtualization environment. It is built off cloud-native software, so that means we're using containers and orchestration technology so that you can scale out and grow dynamically. You don't have to buy a hardware appliance that is limited to X number of APs or client sessions. You can start small and grow into it by just adding more virtual servers, if you will. And then that also provides resiliency with built-in clustering. So you can have a cluster formed for your packet core that, if you need to take one down for maintenance, it's kind of hitless. You can upgrade one node while the others are still operating the network, and you can kind of do that hitless upgrade as well. And then the cloud management is all software in the cloud. But again, it is flexible enough that if you need to deploy it in a private data center, that's an option as well for some of those industries and customers that have very stringent security requirements to run everything internally and nothing in a cloud, for instance.
Nice. So say if I had a Wi-Fi deployment that required 5 access points typically to provide Wi-Fi coverage and density for the users, what is the ratio compared for if you were doing a designer deployment for the CBRS? Would you need like 5 access points as well? Would you need more? Would you need less?
Yeah, so from a coverage perspective, we're looking at a ratio of somewhere about 3 or 4 to 1. So for every 3 or 4 Wi-Fi access points, you might need 1 LTE access point. That's because both indoor and outdoor, we have much greater coverage range. For indoor, we're looking at somewhere between 10 to 30,000 square feet, depending on the obstructions within an indoor space. Outdoor, we're looking at covering anywhere from 500,000 square feet up to several million square feet, depending on, again, which antennas you select. So if you select an omni versus a more semi-directional antenna, as well as then outdoors, there's much higher power levels allowed in CBRS. We can go up to 47 dBm, so that's 50 watts of power. So we can cover really large areas outdoors with LTE and CBRS.
Watts of power?
50 watts, yep. Okay. EIRP.
Okay, so this is like extremely, extremely strong when compared to Wi-Fi. And what is the capacity of your one access point? Like if you wanted to offer like good grade voice data connectivity, how many users would you normally design for using one access point in one cell?
Yeah, so I think per sector, so terminology-wise, each radio in an AP is called a sector. If they're joined together through carrier aggregation, which gets you like almost like a wider channel, then that would be two sectors combined into one. They have to have the same coverage footprint. But per sector, I believe our indoor units, we're looking at 96 active users. So again, there's a little bit of a learning curve here because there's a concept between idle and active in cellular and LTE, where active means they're actively passing traffic through the radio, and if they don't for a few seconds, that session can get offloaded from the radio back to the packet core. So they're still connected, they're just in an idle state, and it can free up resources on the radio. So 96 active users passing traffic at across any second or two is typically our threshold there.
That's a lot. And you said we had like 100 and something megahertz of spectrum available for you to use. So a single sector, single antenna, single radio, what chunk of a spectrum does it use?
Yeah, so we have 150 megahertz in the band, and each sector can use LTE is a little bit different as it's been adopted for CBRS. LTE as a protocol can use very low quantities of spectrum, I think like 5 megahertz and even lower. In CBRS, it's been limited to 10 megahertz, 20 megahertz, and right now 40 megahertz. So you have some channel width options as well. And with the typical 20 megahertz channel, which is we kind of see in the baseline of what people are going to deploy or we're going to recommend people deploy, we're seeing about 110 megabits down and about 20 megabits upload. So a total channel capacity of somewhere in the neighborhood of about 130 megabits. And that's with LTE. With 5G, that's going to be quite a bit higher. That's some of the enhancements that come with 5G in the next 9 to 12 months is some better spectrum usage, some more flexible channel width options, new spectrum bands, as well as then higher modulation techniques.
But still, when you consider so many clients being associated to one of your CBRS access points, it's still very impressive. So from practical perspective, it's good enough. I believe
it's
work.
A lot of the physical layer is very similar to Wi-Fi. So OFDMA, just like Wi-Fi 6 has been adopted. So I mean, at the physical layer, a lot of it looks very similar to Wi-Fi. It's OFDMA. It's very similar 256 QAM type of modulation, or higher with 5G to 1024 QAM. So a lot of that looks very similar. The differences get into how the OFDMA channel structure happens with the subcarriers and the tones. And then at the MAC layer, a ton of differences like we kind of highlighted with the interference coordination.
So if I'm a customer, why would I go for CBRS over Wi-Fi?
Yeah, I mean, that brings up, an interesting point of what the differences are and what some of the use cases that LTE might be a better fit for than Wi-Fi in a private environment. I think, first one we've already talked about a little bit, which was the coverage range. So if you have indoor, you're getting 3 to 4 times the amount of coverage. Outdoor, you can get 10 times or more the amount of coverage. So if you have a large area that you need to cover and get client devices connected, it's going to be more efficient to use a cellular or an LTE access point than it is to pepper in a large amount of Wi-Fi APs, or especially with backhaul considerations. So typically in Wi-Fi, you might have to leverage some mesh solutions to get out to some locations where you can't get cabling. With LTE, you could have fewer base stations that do have fiber or Ethernet backhaul and cover that large area pretty easily. Yeah, go ahead.
No, I was going to say, and I was just thinking about it, like, is this really mainly catering just for purely like mobile devices, as in like mobile phones? Because say, what about my laptop? If I went with a private CBRS deployment, what about my MacBook? How would that be able to connect? What would that use? Or is you purely just targeting spaces that would have mobile phones, and that's what they're trying to cater for? Or how do other devices connect?
Yeah, so from a device ecosystem perspective, we're seeing newer mobile devices like smartphones and tablets adopting CBRS. The good thing is that for device ecosystem, CBRS is just another LTE band that can be supported by the chipset. So Qualcomm, for instance, has been shipping their chipsets with band 48 support, which is CBRS in the US, since late last year, like September or October. So any cellular device that comes out should have a high chance of having CBRS support in the US.
The iPhone 11 has it, right?
Yeah, the whole iPhone 11 and the new iPad Pro. There's Android devices like LG, the Samsung S10, Note 10 type of devices. And then there's a whole suite of devices that are more either router gateway type devices or embedded type devices for other use cases like industrial and manufacturing and things like that. So there's Cradlepoint routers, there's Sierra wireless gateways and modems that have a number of Ethernet ports on the back end to connect other devices up. There are pass-through type devices like bridges. So there's like BEC devices that take an Ethernet input and can put it out to CBRS. So we're seeing a lot of those use cases that are not just mobile devices, but they're devices that are targeted toward the more that industrial manufacturing, rail yards, shipyards. They look for those hardened type point devices.
So would we see in the future then access points that have CBRS radios as well as Wi-Fi radios so we can combine the two for deployments, or do you think it's going to be completely segregated and separate?
Well, I think probably not initially, at least, because the deployment characteristics are completely different. Since you wouldn't want to deploy one LTE access point everywhere you put a Wi-Fi access point, I think we're going to see it to a large extent initially be separate network deployments. The good news is that with it just being an overlay, with like the Celona APs plug into your own cabling, your own switches as well. You don't need to put in a separate parallel network. You have the flexibility to just do your design and place those LTE access points where they make the most sense. So yeah, definitely not every AP, Wi-Fi AP would be the same targeted location for a CBRS AP.
So they could potentially be used to go through like a PoE pass-through for an access point. So where you've got 4 Wi-Fi access points, you could potentially install one of the CBRS APs either directly cabled to the switch or potentially through an access point. I don't know if do you have any integrations with any vendors or anything like that, or?
Yeah, so our requirement right now is on our indoor units PoE+. So it does require, I believe, around 20 watts of power. So typically, yeah, we're looking at cabling it directly back to a switch that is a 802.3 AT capable switch. We haven't tested any pass-through with other devices. Our APs do have a second Ethernet port for like a downstream device, though, so you can have a video camera hanging off of it or something like that. And then our outdoor units do require a bit higher power because of the higher power output for the outdoor coverage range up to 50 watts. So yeah, we require a separate DC or AC to DC power converter for the outdoor unit, and it typically runs off about 60 watts of power.
Okay, and quite a hot topic right now with people coming back to work in the coronavirus crisis. Do you guys offer any kind of RTLS indoor positioning services using CBRS kit from Celona? Can you position some tags with your toys?
No, there's no like RTLS tagging capability, but what there is we leverage built-in LTE capabilities for location tracking. So that can be most granular, like the cell that a client is connected to. So and then if we have multiple APs, we can do some more triangulation, but that's not a focus for the technology right now. It's just really what's standard with the 3GPP technology. It's definitely not like what you've seen in the Wi-Fi space with RTLS tags or anything like that.
Okay, that's fair enough. But you said you have Ethernet pass-through with PoE capabilities, so I don't see why you wouldn't be able to use like ultra-wideband or something connected straight to your access points indoor to enhance the RTLS capabilities.
Yeah, I mean, definitely not something we've tested, something that we could consider though, I would say. The focus for us is really the private cellular network for the use cases that enterprises may have. And maybe if we could jump back to that, I had a few other, kind of technical use cases that might be applicable that I could share with you guys. We mentioned the coverage.
Of course.
The second one would be, better quality of service or wireless with an SLA. So because of how LTE works with the scheduler with OFDMA, and it controls both the uplink and downlink, we can offer very granular, predictable quality of service for applications. So think of applications like voice over IP or video performance and streaming, where you really want to give a high quality SLA. Some other use cases for that are automation. So we've been working with a lot of manufacturing or industrial companies. They're looking to automate their operations in these areas, and there's a big safety consideration with that. So if they're going to be automating these pieces of machinery, they want real-time control traffic like Profinet type traffic or video streams for a remote operator to control the unit to be guaranteed a level of performance. And we can do that with LTE. So as part of Celona's kind of differentiation, you can define business rules for your applications, apply very granular QoS, meaning what minimum throughput do I need for that application, what's my latency threshold, what's my packet error rate threshold, what's my jitter threshold. And the LTE scheduler, both in the radio and in the packet core, as far as compute and memory resources, will optimize the system to make sure that we can get that traffic through. So we take into account the channel state of the clients and what modulation is best for them, and we can schedule their transmissions on the network to make sure that they get that data through. So that's probably the second huge benefit with LTE, is that quality of service that's really, really robust. The third one would be, the native mobility and roaming aspects of cellular. So from a cellular perspective, roaming and handoffs between access points are coordinated much more standardized fashion on the back end. There's a couple of different methods that handoffs can happen, either controlled by the infrastructure or initiated by a client in kind of more of an emergency situation. And those are very standardized. Those are rigorously tested before devices are certified for cellular operation. So even in low speed situations, like let's say warehouses with forklifts or pallet riders and things like that, sometimes roaming can be an issue. And so those might be opportunities where a cellular network might make sense as well. And then the fourth one is just density of deployment. So the LTE and 5G technologies can handle, let's say, massive IoT deployments better than Wi-Fi can, just because they can handle client density much better. So I talked a little bit earlier about the idle versus active state of clients. This really allows us to handle very high density of IoT sensor deployments in a compact space. So if you're thinking retail stores or anything where they might want to put in hundreds or thousands of IoT sensors in a small space, this could be easily handled by LTE without overloading like the connection capacity of an access point or system.
It's a typical question that we ask when we come to do our Wi-Fi design is that when they say, how many clients can this access point support? And it's like, well, how many active clients is really the question. Like, what applications are they going to be using? Is it voice? Are they going to be sending huge CAD files, or is it just purely, they've come in, their phone and their watch and their laptop's connected to the AP, and then they've sat down and then they've started using the laptop, but the phone and the watch isn't doing anything. So, that kind of comparison, I think people from the Wi-Fi world will understand that very well.
And also I can see the benefit of your roaming approach, where it's the infrastructure that makes the decision mostly about the roaming of the clients, which will not be affected too much by the algorithms done by the devices manufacturers, right? So each manufacturer handles roaming in Wi-Fi differently, using different green diamond algorithms. So in CBRS, probably it's not an issue.
Yeah, I think that's a fair statement to make. And I think, what you should, understand is that from a private cellular perspective, you're kind of getting all of the benefits that has been done in the cellular ecosystem by the carriers. So the carriers are very controlling of their networks. They certify all these devices to make sure that, they operate to the standards that they require, not only for mobility, but for, modulation. And, there's all of these very strict thresholds and tests that they go through to certify devices. And you're kind of leveraging all of that when you deploy a private cellular network. All of these clients are certified to operate to a carrier standard, and that's flowing down to you at an enterprise level. You can deploy these clients, and they work just as well as they will for a mobile network operator.
Oh. Yeah, go for it, Matt.
No, whilst you were talking, I just had a few questions just to pop and fire into my head that I was thinking of. So the first one being that when you come to do your design or for your CBRS deployment, do you have to take into consideration when you're deploying your APs outside interference from other cellular networks, like we would do with Wi-Fi, which then led me on to think of, actually, when we go to do a Wi-Fi design or deployment, we would use software tools like Ekahau with some like a Sidekick or using other kind of like Wi-Fi adapters. How do you guys do your designs and deployments and validations? Like, what software do you guys use? What do you have? Special antennas? Is it the similar sort of process? Sorry, I chucked a load of questions at you then. It was all just flying into my head whilst you were talking, and then I thought I'll throw them out there for you.
Yeah, no worries. So from an interference perspective, it starts with understanding that every CBRS radio does have to query and get a spectrum grant from a backend database. So a backend database essentially has a record of every radio that's deployed and its GPS coordinates or location within an accuracy of, I believe, about 50 meters or so. So it knows where everything's deployed and in what power levels and what antenna orientation. That's kind of all the information that has to get registered when you bring a radio online. For Solona, that happens in the back end. You bring up a radio. It's indoor, it's tied to a site and a location. Outdoor, it's got GPS sync. Our indoor ones have GPS as well, but the likelihood of getting a GPS sync indoors is a little bit less. So it registers automatically with that backend database. And the system, kind of like RRM and Wi-Fi, there's a concept called self-organizing network in LTE, which we implement. And that essentially takes all the radios in a site or a location that's managed by the packet core, understands what spectrum is available for each of those radios independently from the database. So again, that incumbent protection, each of these radios is at a specific location, what would it interfere with and what spectrum is available for each of those radios. And then it optimizes that to say which channels and which layout to make sure that they don't interfere with one another and do that frequency reuse as optimally as possible. That's all happens automatically in the back end through our system. So from a design perspective, you don't need to do static channel planning. And in fact, you can't do static channel planning in a CBRS network, since you do have to go to the database and get a spectrum grant. It's just not possible to statically assign a channel. You have to leverage what the database tells you is available for that radio. And then from an interference mitigation perspective, again, within your own network, everything is coordinated on the back end through the scheduling to make sure that that's minimized. And then from an external network interference perspective, again, that kind of comes through what you get back from the SAS. So if there's 150 megahertz and the SAS tells you for this radio, you have access to this 110 megahertz, you're guaranteed that 110 megahertz means it's not going to interfere with what's nearby you. That happens for every radio. So there's really much more centralized coordination of that. Rather than allowing each individual radio to kind of sense its own environment and figure it out on the fly, it's just more centrally coordinated.
Even across clients, if you have multiple clients in enterprise world all using CBRS, you still have access to. Oh, that's quite nice.
Yep. If I have my building and a neighbor enterprise has their building, they're both registering with the backend SAS database or Spectrum Access System database. And so all of the radios across organizations are registered in that database. And so when you bring up your radio, you're querying that SAS and it tells you what's around you and what you should avoid.
Nice. And it's outside, it's a plug and play. So you plug in your radio and you don't have to do any map services, calibration stuff where you drag and drop the access point onto the map. It will just use the GPS coordinates and put itself on the map while registering to your database. Is that as easy as
From a database perspective, yes. I would say from a network admin perspective, you still want to go through a design process to know how many APs and where to place them in your environment. So that starts with us with the Celona Network Planner. So that's kind of, again, what I mentioned as the rough order of magnitude of how many APs do you need for a given use case. And it also will tell you what the spectrum availability is for that location. So how much of that.
It's a video podcast. Would you like to show us some, bells and whistles from your planner and some use cases maybe, so we can visualize it in front of our eyes to understand and...
Yeah. I can't show you the network planner right now. I think they're doing some back-end work on it, but it's at planner.celona.io, and I could show you a video if you'd like of it. It's very simple, though. You put in an address and the amount of square feet, or draw on a map the coverage area, and it'll tell you what spectrum is available and how many APs you need for your use case. To do a more detailed design, especially like indoors, you might still want to leverage a predictive modeling tool, like an IB-Wave type of tool where you're actually putting in a floor plan, drawing walls, and putting access points on a map. That's just more for you to understand how coverage will propagate from a very accurate perspective through a building. So, it's always good to do design work up front, and it's no different than Wi-Fi in that respect.
Okay, and IB-Wave would be your tool of choice to do predictive design inside the buildings.
Yeah, we've been using IB-Wave here at Celona. They support indoor cellular network planning. They have small cell CBRS radios within their tool. You can put onto a heat map and get accurate prediction for both coverage, SINR, all those good heat maps that you need to design for.
Nice. Okay, so let's take a look at the video that you have there.
Yeah, give me 1 second to pull that up here.
No problem.
And I'll make sure that I try and transition us nicely between video and our faces on the video cast, whilst Andrew is just loading that. But we will speak through what's happening on the video, so you guys can, if you're just listening only on the podcast, you'll be able to get an understanding and feel for what's happening. So whilst Andrew's just having a look for that video, and then he'll share his screen for us so we can see.
I'm actually bursting to see it. Have you ever seen CBRS in action, Matthew?
I have not. This will be the first. This is why I was really looking forward to this podcast, because I knew that I would be I'd be learning lots from it.
All right, let me know if you can see my screen.
Yeah, I'm just dropping us all off now, so it's just your screen that we can see.
And you can see the network planner here?
Yeah, we can see the network planner.
Okay. So this is just a web-based tool, and you can go to planner.celona.io to access it. And so it's free to use. So what you'll see here is we're just going to start by putting in a physical location or address into the tool. And once we had the address populate, what you'll see here on the right-hand side is it's checking for spectrum availability. So what it's doing is at that specific location, this is one in California, it checked out of the 150 megahertz, how much spectrum is available at that location for your private deployment. And here it looks like there's 100 megahertz available. What happened next is we put in a facility type. So there's a lot of regression modeling that goes into the tool on the back end. So once you pick in your facility type, it has a lot of models on the back end, and it does some regression modeling about the average path loss and attenuation characteristics for that type of environment. And then you put in either a square footage, if it's an indoor space, or if it's an outdoor space, you can choose the area on a map and draw it on this kind of Google map insert. And then what happens is you'll see it populate with how many, from a coverage perspective, how many APs you need to cover that space. So with 100 megahertz available to cover that 50,000 square feet, you're looking at 2 indoor access points. And then what you can do is go down and let's do I think we're going to do an outdoor one here. Now we're going to do capacity planning next. So if you put in the number of devices and the kind of capacity or throughput each one needs, Then what you'll see is that it'll update the plan to tell you a revised count of access points to meet that capacity requirement. So you can do both coverage and capacity-based planning within this tool. And this is good for, upfront at the start of a project, getting a budgetary estimate in place before you want to go to the effort of doing an in-depth design with like an IBWave type tool.
Nice.
So that's kind of like a first step in your network planning. The other thing to note is that this is fully API driven. So if you have, let's say, a large number of sites that you need to plan for, you don't need to do this manually through the UI. You can just hit it with an API and get an estimate for a large number of sites given their characteristics. So you could plan for 100 or 200 sites in a matter of a few minutes.
Wow. Was there anything else on the planner that you wanted to show us?
No, that's it with the planner. The other thing I could do is show you a demo of the Celona Orchestrator, which is our management interface, as well as then potentially a look at some of the wireless QoS with a couple of video streams to show how QoS can be maintained across an LTE network, if you'd like.
Yeah, sure.
Okay. So here you should be seeing the Celona Orchestrator, which is a public cloud management interface. Can you guys see that okay?
Yep, absolutely fine.
Okay. So, this is where you'd go for management of the system. So here on the dashboard screen, you can get a view of all the sites across whatever time range you want. And it'll tell you how your infrastructure is doing from a Celona Edge is our packet core, which is comprised of nodes and clusters. So you can have multiple nodes in a cluster for resiliency and capacity. So for instance, let's say you might have 3 virtual servers that are nodes in a single cluster that serve as your packet core. And then you can have your access points and then your client devices. And you have overview of the network metrics as far as the high-level metrics of the network and how it's performing, total utilization, availability, some standardized LTE type of metrics out of the network. And then you get metrics on QoS that you can define. So if you have any QoS policies defined, you can see how well those are meeting their SLA. And so this is our lab environment, so we do a lot of testing here. So we're intentionally probably breaking some stuff to make sure it works and whatnot. But you'd get a view of each of the QoS policies, or micro slices as we call them, and how well we're meeting that SLA, what percentage of the time we're meeting it. And ideally, that would be like 99, 100% of the time. But that's just some high-level metrics, and then you could also drill down instead of all sites into specific sites and see what the metrics look like for each site. The management of the network is hierarchical. So you define your edge clusters or your packet cores. You assign access points to those packet cores, and that's done through the sites. So you might have a site here called this California one. We have one packet core assigned to that site, and any access points that are assigned to that site would be assigned to that packet core, that Celona Edge for operation. So that's kind of how you tie the two together. You have access points at sites, and then you assign a packet core to that site so that those access points know where to communicate for their control and data plane traffic. From an edge cluster perspective, then, you can see the edge clusters that are defined and how many nodes are in each cluster, whether it's active or inactive. Here you can also have an inventory of edge nodes that are unassigned. So let's say you're adding stuff into your network for growth or resiliency. You can bring up a new virtual server. It'll register in the system, and then you map it to a cluster for operation. IP domains is where we can then, on a per packet core basis, define how clients should get bridged onto your enterprise network. So here you can see if we defined one, you could have, let's say, a VLAN 10 IP domain, what DHCP server it should go through and what VLAN number it should go through. Add that into the system, and the packet core then, once you map it to a client device group, would bridge those clients into that VLAN on your network. So we can We can have a few different modes of operation for our packet core. We can have it have its own IP scheme for the clients, and then NAT out of the packet core into your network. So a traditional NAT mode. We can also route traffic, so you can define your own IP subnets that match your IP addressing within your enterprise, and then that can be routed through the packet core. Or you can bridge clients directly into VLANs for an upstream router that would hand out IP addressing for those clients. So 3 different modes of operation there you could use. Go to the access points. You can see access points, what their details are here, whether they're up or down, what category, outdoor or indoor they are, and what site they're assigned to. You can also drill in and see the radio details for channel and power levels and things like that. The devices tab is where you manage SIMs or subscriber identity modules. So everything in Cellular is authenticated through a SIM credential. There's no concept of unsecured network. And so you, as part of the Celona solution, we provide you with SIMs to put in your devices. And then you would assign those SIMs to specific devices. You can add them into device groups, which are critical for not only IP addressing and which VLAN they might go on into your network, but also you can tie it into QoS and what QoS policies these devices can get.
Can I ask a quick question here?
Yeah.
When you put your SIM card into a corporate device, are you tied to your CBRS network, or could you possibly use this device outdoor as well when you leave your office and go home and, just use your Vodafone or whatever, provider you have outside of your office? Or would you require dual SIM devices to work at both your corporate environment and outside of it?
Yeah, so the SIMs that are essentially private SIMs are only valid within your enterprise network. If you're looking for access to a public MNO network and to have, one device on both, then you're looking at either a dual SIM device that has 2 SIMs, one for the private and one for the MNO network, or you're looking at having an MNO SIM and a back-end roaming agreement with them so that if they come onto your private network, you can authenticate that MNO SIM back to the MNO's packet core. And that's possible. It just requires a roaming agreement with the MNO operator. And so we're investigating that with a lot of partners as well. The standard is there. Yeah, it's possible. The standard's there. Our network equipment supports all the standard 3GPP interfaces for roaming with the mobile network operators. It's more so just the business negotiation for those roaming agreements.
Okay, it seems like dual SIM is cheaper option.
Yeah, and it's more in control from an end user or corporate perspective of not having to involve the MNO in that business arrangement. But both options are viable.
Okay, cool. Thanks.
Yeah, and then so that's really just the back end work of getting your network up and running from a Celona Edge perspective and an AP perspective and a device client device perspective. The other thing to note about these SIMs are authenticated, and that functionality, that authentication function is within the Celona Edge or the packet core. So you don't need an external AAA server as well. So everything's kind of self-contained. As long as the SIMs are activated within your system, they will be able to authenticate those devices onto your network. So you don't need to rely on an external radius or AAA server as well. And then once you have the devices on your network, then it's all about policy as far as device groups, applications, and microslicing, which our QoS is. So device groups are pretty simple. You just have a device group and you essentially group your devices into those buckets. And that's leveraged when you go to define your microslicing. So, prerequisite steps to configuring QoS are to group devices and then to define your applications. So let's see here, we might have some applications defined like CCTV or Zoom video. You could define Skype here or voice over IP or whatever your enterprise application is. It's defined by source IP port, destination IP port, and optionally a DSCP tag that we can inspect. And then you could place that into a QoS profile. So let's say we have a Zoom QoS profile here. We can give it a specific priority. So here we're looking at, QCI 5 in the cellular world, which is kind of just a best effort queue. We can also do a guaranteed bitrate queue. And so we could say, QCIs 1 through 4 offer us a guaranteed bitrate, and we could put in, I want a 5 megabits per second guaranteed throughput up and down for, let's say, a Zoom video call. And the system would guarantee that 5 megabits to any clients that we map to this policy. And we map those down here to a user, one or multiple user groups. And then here we also tell it which applications apply to this quality of service queue. So we selected one or multiple applications, one or multiple client device groups, and they're going to get this level of QoS when they come onto the network.
Nice and easy. And all the groups and all the profiles, they are predefined, I guess, so you don't have to have PhD in QoS to configure it in your network.
Can you state that again? I'm not sure I understand the question.
Yeah, so all the profiles for your QoS, like priority 1, priority 2, these different metrics that you're using to prioritize some application on top of the others, they are predefined, so you do not have to really dig too deep into.
Yeah, from an LTE perspective, these are standards based and predefined. So there's QCIs 1 through 8. So 1 through 4, you can offer a guaranteed bit rate. 5 through 9. They do not offer a guaranteed bit rate, but they do have separate priorities and other packet error and loss rate, like 10 to the minus 6th, and a packet delay budget, which is your latency budgets. So those are kind of predefined in the LTE standard. They come built in. What you can do though is you can define the guaranteed bit rate for those queues.
Okay, it looks very simple and sleek. I'm just aware that Matt, you have a meeting in like a minute from now.
Yep.
Okay, so is it a good place to wrap it up? And if we want to discuss more stuff about the CBRS, which is extremely interesting, especially in Europe, where we didn't, hear too much about the CBRS, and it seems like it's going this way too. Every time that you have something new that you would like to present and discuss, we are super happy to have you back in our show, and we can pick up where we left off.
Yeah, I'd love to be back. I think this is a good wrapping point, for an overview of the technology, and then would love to come back and show you guys what we're doing. We could highlight an actual demo, perhaps, of our quality of service, and maybe discuss, more globally what that looks like for shared spectrum across the UK and Europe and things like that.
Definitely, we would be very interested to see that, especially if you could show one of the demos as well. That'd be great. And I just want to say good luck for the Mobility Field Day later on today, and thank you very much for coming on our show to talk about CBRS. It's been very interesting for me personally. I feel like I've learned a lot, and I'm already looking forward to listening and watching back to the podcast to try and take in even more information.
Well, thank you for having me. I appreciate it.
Pleasure. Thank you very much, guys. Take care and have a lovely day.
Thanks. Bye.